I'm going to show you how to solve trig equations. Now, by the time you're solving quadratic trig equations, you're going to be working in radians. So I want you to assume that all angles are measured in radians. Radians seem unnecessarily confusing. However, if you were to try and say determine the sine or the cosine of an angle without using your calculator, you'd find that if you're using radians, you can do a power series expansion and get the right answer. Furthermore, in calculus, when there's some sort of round geometry to a problem, you'll find you can break up the problem into these polar rectangles, we'd call them, where this arc length is equal to the radius of the problem multiplied by that angle, but again, that only works in radians. So despite the numbers looking a little more confusing, it's very important to master working with radians because there's certain problems that do require it. Okay, first problem we're going to solve is 4 sine squared x minus 3 equals 0. Now, this is a cooked problem where we're looking for an exact value. So let's find an exact value. Find an exact value, which means we're not going to be taking decimals and then rounding. We're going to find an exact value where x is in between, let's go easy here, 0 and 2 pi. So we're going to find all of the solutions that work for this equation where x is between 0 and 2 pi. Okay, I've just subtracted 3 from both sides. And then I'm going to divide both sides by 4. Now, this is the sine of x all squared. I know the notation may look a little bit funny. This is an aside. Remember this. If you see this, what does that mean? That means that you're taking the sine of angle x and you're squaring the whole thing. This is just the shorthand way that we write that. When you see this, always think that. If someone was to write this, what they would mean is you take x, you square it, and then you calculate the sine of it. So this is not the same thing as sine x all squared. We write it this way. So back to the problem at hand. We had 4 sine squared x minus 3 equals 0. We added 3 to both sides, divided both sides by 4. Now we're going to get rid of that squared symbol by square rooting. But because this is a quadratic, we must include the plus and the minus solution. So I've got the sine of x is equal to plus or minus the square root of 3 over the square root of 4. Now the square root of 4 is 2. See, this works because if you were to square root 3 over 2, you get 3 over 4. If you were to square negative root 3 over 2, you'd also get 3 over 4. So this is actually 2 solutions. Our 2 solutions are the sine of x is root 3 over 2, or the sine of x is negative root 3 over 2. So starting here, if you add 3, divide by 4, and then get rid of that squared by square rooting both sides, and you understand that because this is quadratic in nature, there are 2 possible solutions, one where you add and one where you subtract the square root. That brings us to here. We have 2 equations to solve now. And remember, x lives somewhere between 0 and 2 pi in this question. Okay, where is the sine of x equal to root 3 over 2? We could use our calculator, but because root 3 and 2 come out as special triangles, we can find an exact value. If I draw this right angle triangle, where the opposite is root 3 and the hypotenuse is 2, we recognize that from our special triangles. This is pi over 3. So one of our solutions, my first solution is pi over 3. Because in that special triangle, with pi over 3, pi over 6, we have 1, 2, and root 3. Now please review special triangles if this is a new idea to you. Now I'm looking for every solution between 0 and 2 pi. So this is one valid solution. However, I will also have a positive sign if I go up here. So this angle here, that's my first angle that works. But my second one, I'm going to call it x2, lies over here, where again it has a sign of root 3 over 2. So if this is root 3, then that's 2. So this must be pi over 3. And since a full rotation is pi, this angle x2 is going to be, I said a full rotation. What I mean is a reversal rotation, so a 180 degree. Since a 180 degree rotation, so from pointing right to pointing left, is an angle of pi, then that means x2 is pi minus x1. This angle in here is x1. This obtuse angle here is pi minus x1, because this is the same, this is a similar triangle to that one, just on the other side. So that makes this pi minus pi over 3. So it is 3 pi over 3 minus 1 pi over 3. It's 2 pi over 3. So my two solutions so far for 4 sine squared x minus 3 equals 0 are pi over 3 and 2 pi over 3. Now over here, sine is negative if I am down here or down there. If I'm down here, that's negative root 3, that's 2. My angle in here is pi over 3, but my angle between 0 and 2 pi has got to be a positive, so it's this reflex angle that goes all the way around here. That is my x3 value. And from looking at this picture, x3 is going to be 2 pi, because 2 pi is a full rotation, minus pi over 3. So that is 6 pi over 3 minus 1 pi over 3. It's 5 pi's over 3. And finally, I've got one more solution over here. Call that x4. And if we've got negative root 3 over 2, that makes this angle in here pi over 3. So x4 is going to be pi plus pi over 3. So it's 3 pi over 3 plus one more. It's 4 pi over 3. So we've got 4 exact solutions. X is equal to, I've got them all here, pi over 3, or 2 pi over 3, or 5 pi over 3, or 4 pi over 3. And all of those are considered exact valid solutions to this trig equation here. Now you can verify any one of them by testing those values in there. Let me just try a random one here. So let's see if 5 pi over 3 works. So remember we had 4 sine squared x minus 3 equals 0, and I want to test to see if 4 pi over 3 is a valid solution. So I've got 4 times the sine squared of 4 pi over 3 minus 3, and I'm going to see if that's equal to 0. So this is 4 times the sine of 4 pi over 3 all squared minus 3. And the sine of 4 pi over 3 4 pi over 3, 3 pi over 3 would be here. 4 pi over 3, we rotate another pi over 3. It's here, where that angle's pi over 3, which makes this root 3 and makes that 2. Well, it's a negative root 3, and that's a 2. So the sine of 4 pi over 3 is the x over r value here, which is negative root 3 over 2. So this is 4 times negative root 3 over 2 all squared minus 3. Now, negative root 3 squared is 3, 2 squared is 4. So this is 4 times 3 over 4 minus 3. It is 3 minus 3, which is 0. So that proves that 4 pi over 3 is a solution to the original equation. And you could verify, check and verify that each of these 4 angles will work in a similar way. To recap, when dealing with an equation like this, when you're looking for an exact value, you solve the trigonometric equation to determine the possible values of, well, in this case, sine x. So sine x could be this, or sine x could be that. Now, in recognizing that these numbers come out of a special triangle, and a cue to you being that you've been asked to do a question where you're looking for an exact value, you're going to draw out the special triangle around a coordinate axis, always remembering that the sine of an angle is defined as the y value over the r value. That's what I'm using as I draw all of this out. You insert your special triangle values as appropriate, and you can always check and verify that you've done this correctly by plugging any of those solutions back into the original equation.